Hello everyone. Let's start our presentation on Introduction to Textile Testing, Fabric Construction and Stability. Learning outcomes. This presentation will explain how to describe fabric construction, how a fabric is constructed directly influences its price. So it is important to have this knowledge whether your interest in the topic is commercial or technical. You will learn about the use of standardized test methods for determining fabric construction. You'll also learn how to determine dimensional stability of fabric when washed, dry cleaned, etc. Basic fabric construction. Fiber content refers to the fibers in the overall fabric. What is the entire fabric made out of? That's what we are referring to. 100% cotton or 65% cotton, 35% polyester, and so on. That's what we are talking about. Note that fiber does not mean individual yarns or threads in the fabric. Fiber content is determined by subjecting fibers drawn from the fabric under microscope and observing their shape or burning them and observing their burning behavior. Of course, these methods cannot be used to accurately determine the percentage of each fiber in a fabric containing multiple fibers. That can be achieved by using chemicals to dissolve one fiber and leave the other fiber unaffected. As an example, if 10 grams of fibers were drawn from a fabric containing cotton and polyester, and if only 3 grams remain after dissolution in sulfuric acid, and to be precise, sulfuric acid of 75% strength, it can be concluded that the fabric is 70% cotton and 30% polyester, since the acid can only dissolve cotton, not polyester. Yarn number or yarn count refers to the fineness or coarseness of yarns or threads in the fabric. If these yarns were made of steel, we could express their fineness or coarseness by stating their diameter. Yarns are soft, so they are described by stating their length and weight together. Yarn number is commonly expressed in tex or denier or English cotton count. A 20 tex yarn indicates that 1000 meters of it weigh 20 grams. A 20 tex yarn is coarser than 60 tex yarn, as an example. A 180 denier yarn indicates that 9000 meters of it weigh 180 grams. A 180 denier yarn is coarser than 540 denier yarn, as an example. A 20 English cotton count yarn indicates that 20 times 840 yards, that is 16,800 yards of it, weigh 1 pound. A 60 English cotton count yarn is finer than 20 English cotton count yarn, as an example. Thread density refers to the number of threads per centimeter in the fabric in the length way direction and the width way direction. A purpose-made magnifying glass or pig glass is used to count the number of threads per centimeter. Threads per inch is another way to express thread density. Fabric weight is usually expressed in grams per square meter. A 100 square centimeter circle or 10 by 10 centimeter square cut out of the fabric is weighed on sensitive scales. The weight so obtained is multiplied by 100 to arrive at grams per square meter or GSM. Ounces per square yard is another way to express fabric weight. A 10-ounce denim, for example, refers to a denim fabric weighing 10 ounces per square yard or 339 grams per square meter. Dimensional stability refers to the change in dimensions, shrinkage or growth of fabrics because of washing or dry cleaning or relaxation. A fabric is marked with benchmarks and subjected to washing or dry cleaning and then dried in accordance with its care instructions. The distance between the benchmarks is measured again. As an example, if the distance between benchmarks was 250 millimeters initially and was 240 millimeters after washing and drying, it shrank by 4%. Then divided by 250 expressed as a percentage is 4%. On the other hand, if the distance between benchmarks were to be 260 millimeters after washing and drying, it grew by 4%. Let's take an example. A fabric construction specification reads as follows: 100% cotton, 120 GSM, 40 by 40, 120 by 64 plain. This specification means that the fabric is a plain weave made from 100% cotton. It weighs 120 grams per square meter. It's constructed from 40 English cotton count warp and weft each, and that it has 120 threads per inch in the length direction and 64 threads per inch in the width direction. These construction parameters, together with the finishing treatment the fabric has been given, will influence its dimensional stability. In comparison, another plain weave, 100% cotton fabric that weighs higher, say 160 GSM, has finer yarns, say 50 by 50, and higher thread density, say 132 by 72, is anticipated to be justifiably higher priced than the example fabric above. Conclusion: fabrics may look and perhaps even feel similar at first, but in order to compare them, they need to be subjected to tests to determine their fiber content, yarn count, thread density, and weight, together with their dimensional stability properties. Such comparisons reveal the true difference between similar looking fabrics. This is a great tool for negotiating a more suitable fabric for a given end use and negotiating price. Thank you for your interest in that presentation. Please don't forget to subscribe, show your likes or dislikes, and come back with any comments you may have. Thank you.